So what I want to do really is just to give an overview of the algorithm that we use and how to represent, how to do big num in C++ without really using any library, because it's not really necessary. You don't need to go to Python or import a big library. You can just do it itself. It's very easy if you are not doing if you don't need a very generic big num. um, if you don't need like many features. um, in this case we just want to convert a binary number into its decimal representation and print it out. And the way we do it is so let's delve into this. So the big problem when you are printing binary numbers is that you don't really have any libraries that can print integers that with more than 64 bits. With C++ or C, you can do a printf, let's say for 32 bits, this D, and you put your number here, and that's it. That's what you can. You have support for this, and even if n is 64-bit, you just put an L, and you have all the glibc, which is the C library. It's gonna do it for you. Now, if you are trying to pin 2 to the power of 10,000, that's a completely different game. So you can't really you can represent this. Obviously, you can. You just it's just a series of. You can divide it in a series of 64-bit numbers, integers, such that this is the number, such that n is equal to the sum of 2 to the power of j. J going to or times the bit j, right? This is going from 0 to 10,000. You can represent this as a series, and this you can then or you can do sum of let's call it I j. So it's I being an int 64 times 64 to the power of j, and j is going from 0 to 10,000 divided by 64 plus 1. So you divide in 64-bit chunks. You can do this, and it's, I don't know how much is 10,000 divided by 64. Or you can do is instead of representing all these numbers in binary, you can each of these 64-bit or 32-bit chunks can represent a number in base 10 in such a way, and that's the basic idea behind this way to do big num, in such a way that this number inside can be printed with printf. So we can in some way we can reuse what we have already in the operating system, not in the operating system, in the C library, to generate this big number without going and reinventing the wheel. So the way to do it is we have a number n, and we represent this number n as a sum of a coefficient or a number, and this is the Cj, times 10 to the power of m j, right? And with the assumption that Cj is less than 10 to the power of m. Let's give an example, not to be so abstract. Let's say that I have the number 379. I can represent this as divided in chunks. In this case, I have m equal to 2, right? This is my number n. So this is going to be 789 times 10 to the power of 0 plus 83 times 10 to the power of 2 plus 2 times 10 to the power of 4. So you see that this is 2 times 0, this is 2 times 1, and this guy, and the last term is 2 times 2. And this is the j, right? J equal to 0, j equal to 1, j equals to 2. So, and every one of those is stored in its separate bin. So in this bin I have 2, 83, and 79. So j is equal to 0, j is equal to 1, j is equal to 2. Of course, in this case we are using m is equal to 2, but if we divide in 32-bit chunks, so if each of these boxes is a 32-bit number, we can have m equal to 9, and the reason for that is that 2 to the power of 32 is some number, I don't know it, but it's 2, 4, it's like 10 digits. So by using 9 digits, I guarantee that the number that is here inside is less, can be represented by with using 32 bits. And because of the carry, and I'm not going to explain this now, you have to comply with this. 2 to the power of b has to be less than 10 to the power of m. So in the case of 32 bits, m is equal to 9, and b, this b is equal to 19. So we are effectively using 19 bits on each, not 19, it's 29. We are kind of wasting 3 bits in each box, but that's, if you use 30, it doesn't work. And the reason is once you add the carry, you don't want to the sum of the number plus the carry to overflow. The algorithm we're gonna show later. So, all right. So what we wanna do in this case is we want to compute 2 to the power of 10,000. And what we do is we create these blocks of this hybrid power of 10 numbers, and we keep multiplying. We put just initially 1 here, 0 and 0 in the rest, and then we multiply this number by the maximum power of 2 that we can. In this case, the maximum power of 2 is 2 to the power of 29. When that happens, we, as an example, let's have here Let's do a small version of it first. If I have 4 bits, then I would have 2 to the power of 4, which is 16, right? So I could use numbers from 0 to 9. So every let's say an example, just a small example. I don't want to write the big numbers. So each of these boxes is 1 digit, so m is equal to 1. If you want to do several digits, let's say, what you can do is, if I want to do 100, so every box can hold 0 to 99, then the biggest power of 2 is 128, so I need to do 7 digits. Of course, I mean, there is no byte with 7 bits, so you go 8. So every one is 8 bits, right? So you take every 8 bits. Then I can represent, as in that case before, let's take this number, is 28379. In order to compute 2 to the power 10,000, what you do is you multiply these numbers by the maximum, by the biggest power of 2 that's less than 100, and that is 64, which is 2 to the power of 6. So you keep doing that. So you multiply by 2 to the power of 6, then multiply by 2 to the power of 6, and you keep doing that until you get to the end. This series is equal to 2 to the power of 10,000. Of course, the last one is going to be 2 to the power of, unless, you know, if you sum 6, it's going to be 10,000, which is not. You have like a broken, a smaller power of 2 here. But then what you do is you multiply. When you multiply 79 by 2 to the power 6, you're gonna have a number. So 64 times 79. Let's see. Calculator. Where is the calculator? Okay, that's great. 64 times 79. 5,056. So this is 5,056. Obviously this number is bigger than 100, so we have to do 5,056 divided by 100, and 5,056 mod, let's use mod 100. This is gonna be 56, and this is going to be 50. Then what will happen is, and here you have 56, then you add the carry to the next one, so you have to add 50 to 83, right? Then let's take another one. Then what is done, so we added 50 here, carry, right? And here we have 56. Here there's 83. Then it's 2. When you add 50, then it becomes 50 plus 83. It's 133. Then that 133 again, and multiply by 64, you have a new number. That's called V. Then you do V divided by 100, and V mod 100, and the mod goes here. This is the carry that's added to the next position.